My name's Elliot Williams, like we said. Oh, there we go. Let's get into who this nerd is. I am a lead engineer at Form 3. I've been there for about 3 years now. I'm based in Carmarthenshire in lovely South Wales. Did I get a cheer for Carmarthenshire? Brilliant. All right, so I've been doing Go for just over 4 years and then Dev for 8 plus, really. And yeah, I mean, afterwards, if you don't want to talk to me about Go, you can come and talk to me about either modular synthesizers or board games or most recently in M. Banks' Culture series. So yeah, I just finished the Hydrogen Sonata. Probably doesn't mean anything to most people, so I'll just move on. All right, so let's imagine the scene. You have your cool new service. You've built it. Or you think you've finished building it anyway, and the idea is now we're going to try and take this microservice that is, a Go binary, and we're going to try and get that into production. So there's sort of two main components to this. The first is designing your application for, for being production ready and for being sort of future-proof and that sort of things. We're going to talk about service design, and then we're going to step forward a bit and talk about observability and what you need to do in terms of like a go live checklist, just to get everything, make sure that you've got everything you need just to get that, whatever it is, running out in the real world where stuff breaks and you need to know about it. Okay, cool. So I've based the first half of this talk on something called the 12-factor app methodology, which a couple of years ago, at least for me, was a really useful resource on how to build and model software as a service applications. And it's what I found was it was just a really useful checklist for some design decisions that you should make. And it's probably, this was written by Adam Wiggins, and I think the last major update was in 2017, so I think things have moved a little bit since then, but I think it's still a really useful foundation for for us to talk about, and there's some bits of it I agree with, and there's some bits I don't agree with it too much, but we'll get into that in a bit, I guess. So yeah, the 12-factor app, it's a methodology for building software as a service applications. We're going to talk about applying that to our Go application. We're going to talk about how Go is a great fit for building these microservices. Obviously, I'm preaching to the choir a bit here. So yeah, and then, like I said, we're going to talk about what we need to make next, what we need to do next to make our service production ready. So I guess the first of 12 factors is that you should have a code base, and it should be tracked in revision control. So you have one code base that defines your application, and then you have many deployments of that code base. So there's a distinction between the code base itself and the deployment. Obviously, we should all be using version control. And I recommend as well, which I have on here, is sort of trunk-based development. And what we're using here as well is something I really like called conventional commits. So you start your commit with like feat : and then the thing that the commit's about. And then you have some tooling built into your CI pipeline to detect those commit messages and bump the semantic version of your application as you're merging that in. So that's a really useful foundation for obviously having semantic versioning. It's useful as sort of an append-only log of the different versions of your application. The second, I guess, is dependencies. This is something Go is actually really good at. So you can explicitly declare and isolate your dependencies. You end up with a static binary that you can deploy. You have Go modules, obviously. And I guess it's time to argue about vendoring, whether or not you should vendor your dependencies. My recommendation is that you do. And it's slightly controversial, I know, and it makes your PRs a massive mess to review. But with the target being reproducible builds, I think it's really useful that you have everything that you need to build your application in the code base itself. And that's for, Go dependencies with Go mods, and you do Go mod vendor, and so on and so on. the reason, reason reproducible builds are so important is I know that, you can pull from GitHub directly or from the proxy, but in a production or an incident scenario, some of those things might not work, or you might not want to pull from the internet dependencies just before your production application goes live, which is a pretty safe thing to want to do. And then there's, I guess, on vendoring, the other recommendation is you could run your own proxy, so that you're not trusting someone else's infrastructure. And there's some really good work on that in the Go space at the moment that I think is getting really interesting. And for other dependencies, like, I don't know, libxml2, whatever, you can build into your Docker binaries or your Docker file. And that way you've encapsulated all of your dependencies then. So it's all in the thing that you want to ship. The third factor, don't worry, there's a little break in the middle of all 12 of these. We're going to talk about storing config in the environment. So another way Go works really well for this is that you can use environment variables. It's really easy to use environment variables. There's tools like Viper, which we use at Form 3, which are is really flexible, and it lets you sort of build your application in a way that if you need to, you can sort of, during tests, you can overwrite some config variables. You can say point to like a test version of this database rather than the production one. That sort of or your local version, I should say, rather than a test version. And config should be used for values that would change between your deployments, like what database am I talking to? What is the URL of this API? Is it a real API or a stub one that you've written? Yeah, and also, for more secret values, then you can look at Vault as a secret manager, which is also what we use at Form 3. I can recommend is really useful as a store for secrets that you wouldn't necessarily want in the application's environment, and you'd have a Vault client that then pulls that config live from the application. So the only thing you have to inject is the Vault secret and some tokens and stuff. And then the other thing I would recommend is, and this is going to be a recurring theme, is that you document things, including your config, what every config value does, what its format should be, if it has any defaults. Put all of that in your README of your service, and you will thank yourself in several years when it comes time to change some of this arbitrarily named configuration at 3 o'clock in the morning. Okay, cool. Let me just take a quick drink. Excuse me. So, number 4, and we hinted at this a little bit earlier, is that we should treat all of our backing services as attached resources rather than as part of the application. So you want your code to be as agnostic as possible to whether it's using, obviously, a local version of a database, the production database, or a third-party API, or internal API, or any cloud resources as well. So Go is really good at this because you tend to use URIs for things like the database, and you can just say, give me the connection string, and that should just be handled under the hood. And yeah, and that just lets you decouple your dependencies from your application itself. So there's no code in your application which is like, am I in test mode? So the thing that you're testing when you're doing your tests is the thing that you're deploying. And that's really key as well. I also recommend using sort of mocks and stubs for your development. Also, your internal and external dependencies. So local stack, for example, for AWS is really good at pretending to be various bits of the AWS infrastructure. I'm not sure what's going on in the GCP world at the moment, but I'm sure someone can tell me that this is something you can run. We use Pact for our internal service dependencies. The other thing I really like about Pact is it's more than just a stub. It's doing a whole provider-consumer contract verification flow there. So it uses the test requests that you've defined to also run that against the provider that is the API that you're calling. And that gives you some really robust testing for your contracts internally then. But that's a whole talk on its own. I just suggest you go look it up if you're not familiar. And also one thing we tend to do for external dependencies is either use like a test double tool, like I think like really mature ones in that space are Wiremark and Mountbank, that sort of thing, for testing something that you don't have control of, like a third party's API. But what we tend to do at Form 3 at least is we will write our own fake version of that service, and that allows us to do stuff internally like trigger scenarios that for example, payments is a really common space for us. You could send a outbound payment, and that would trigger a corresponding inbound payment in our tests, and that way allows you to do like full end-to-end testing flows then for stuff that originates outside of your application. All right, cool. The next stage, the build, release, run stage, and I think this might be the most outdated of the 12 factors, because I think or at least the examples that they use on the website, I think the methodology is still good, that you separate your build and test and your run stages. Obviously now the CI/CD space is a lot more mature, so you can use GitHub Actions to run your tests, and then so build, run your tests, and then deploy that or push it to a registry, and then you can use some tools then to some tools in your CI to take that the rest of the way through the CI/CD pipeline. Yeah, as we talked about earlier, that semantic versioning and conventional commits are really good for this, because you have the versions specified of the things that you want to deploy. And as I mentioned earlier, you have your releases, your tags are sort of an append-only ledger, which says, like, I'm releasing version 1.0.1. You do a bug fix, it's version 1.0.2, and so on, and so on. You should also check out, if you're using Kubernetes, we released an open source version of a tool called K8's Promoter, which is, yes, the link is there. And that allows you to be it allows you to customize your releases across different environments. There's a link for our GitOpsCon EU talk that was Adeline and Sam, I think, right? So yeah, go and check that out. I mean, obviously this advice is still really relevant, but I think, like I said, the CI/CD space was less mature then than it is now. Okay, processes. Now, this isn't really relevant to us as well, because we're talking about the context of like a single application, but what it recommends is you execute the app as one or more stateless processes. Obviously in Go you have your binary, but actually it says one or more stateless processes. There's a little bit more leniency here for you to do more stuff internally with Go routines, with different entry points and commands. You can trigger different things. You might want to sort of favor simplicity over complexity for building that out as different stateless processes. Just makes things more complicated. Depends how you are. Depends how you need to scale. But the key point about this is, I guess, that it is stateless. So your application shouldn't have any state in it itself, or at least long term. So to use something like CockroachDB or Redis to keep state of your application. Yeah, and that's it, basically. So I can't remember why I put this in. Oh yeah, I put this in because we are halfway through, and I thought we could do with a break from someone just listing 12 things. So enjoy this nice break while I just have another sip of water. Okay, cool. Number 7, port binding. So you would expose your service via port binding. Go is a really good fit for this because you have your built-in web server. You have no need for Apache and all of that. If you've come from other languages, for example, PHP, you know how painful that is and can be to containerize. And also you should, for your application, you should use and document a static port then, which yeah, like I said, put that in your documentation and define, like, here's what it is, here's what it's serving on where. It's got a HTTP port API on 8080. And yeah, obviously you need to avoid port clashes on services that are running together, but that's sort of less of a problem in Kubernetes because pods have their own IPs, that sort of thing, and you'd map the ports differently anyway. So yeah, in Go, that's really, really simple. You just use the standard library to just do listen and serve, and you've got a HTTP server, so easy. Okay, I've forgotten how to read Roman numerals, but never mind. This is the number, whatever this is, concurrency is 8, concurrency, all right. So this is talking about scaling out the process model itself. We were talking about having our processes, our Go binary, but the recommendation here is that you handle sort of diverse workloads separately. So if you have a HTTP server that is running all of the time versus a worker that kicks off weekly to import some things from a service or a website, those should be separate things. And that's, that depends entirely on your domain, but that's a pretty obvious use case for like microservice boundaries then. That being said, we can talk about the trade-off of simplicity versus scalability. The more scalable you make something, inevitably the more complex you make it as well. So that's a decision for you really, but there's, it depends how much you need your application to scale. Okay, cool. And you should build your applications to scale horizontally. So you could have multiple things using the same resources. And yeah, talking about the single process model. So Docker containers do this anyway. So it's recommended that your Docker container is just running a single process. So when you're deploying that, it's pretty straightforwardly maps to this ideal. Number 9. Disposability. So we want to, what is the wording on here? It's like cattle versus pets, but you want to maximize robustness, like it says, with fast startup and graceful shutdown. So you want to auto-scale for your application, if possible, or handle manual scaling. Whenever you're doing that, you're going to inevitably end up with services starting up, shutting down, and they need to be able to do that gracefully. And you can handle graceful shutdown in Go really, really easily with the SIG-term stuff here. Like that's like a 2-line code example just to listen to SIG-int and SIG-term, and then you have a channel that's going to get notified whenever your application was to shut down. And then you can use things like context cancellation to make sure that you are shutting down your application properly and not just flattening it whenever it's time to go, because obviously there might be stuff in process. And the other thing that I'd recommend as well is that you use a queuing backend for commands, that sort of thing. At Form3, we make heavy use of the CQRS. So that way, when your application shuts down, you allow other scaled instances of that application to pick up where yours left off. And then also, as a result of that, you need to support idempotency because you need to be able to replay messages, you need to be able to queue things and have them be replayed in a way that doesn't break the state of things. So, yep, number 10. So we have dev prod parity. Parity obviously is, it's really obvious now, but you should keep your development, staging, and production environments as similar as possible. So at Form3, we use the whole DevOps thing where you build it, you run it, you're in charge of it whenever it's time for it to go into production, and you're on call for that for those services or the services in your business line. And then again, we're talking about trunk-based development. I'm using the correct emoji here for trunk-based development because I put a deliberate mistake. It was a deliberate mistake in a previous slide where I used an elephant to describe trunk-based development. And apparently it's called, I knew this, obviously, but it's called trunk-based development because of tree trunks, and that makes a lot more sense than an elephant's trunk. So here's this nice diagram from the Oxford Learner's Dictionary. That describes that. Yeah, so why are we talking about this? Oh yeah, so if it's in main, in your main branch, then that means it should be ready to go live. And you should deploy incrementally and often and automatically wherever possible. So for example, we, at Form 3, whenever you merge into the main branch of your service, that tends to get, sorry, 1 second. It tends to get deployed to all of our development environments. And then we're using with Terraform, basically, to different Terraform workspaces for each of our environments to configure the same application in different environments then. So we'll trigger build and run for, plan and apply, sorry, for Terraform in all of our dev environments, and then that gets planned for all of our staging and production environments, and then that the engineer will go through and apply those on those other environments then. Okay, cool. Like we said earlier, so your dev, staging, and production should be as similar as possible. They should run basically the same infrastructure at a different scale wherever possible. And when I say dev, I mean like development hosted environment rather than your local environment. For your local environment, I recommend something like Docker Compose, or even like a whole Minikube or a kind cluster to simulate as closely as possible the real world of your application. Okay, we are nearly done with the 12 factors, don't worry. So number 11, logs. And this one is actually really, really important, especially in terms of observability. And that's to treat all of your logs as event streams. So you're saying in your logs, you're providing loads of context, as much context as possible, with structured logging. We use Logrus for structured logging, and that's just a really nice to use library. And you should include then in all of your logs built into the logger for your application, things like the stack that it's in, maybe the version, that sort of thing. Obviously, you don't want to log sensitive values, but you want to give someone who's reading those logs a story of what is happening with the things in there. So you might want to log, as soon as you know it, the payment ID if you're processing payments or whatever. And then when you search your logs for this payment ID, you can see, oh, this has followed this journey. And then you can build that as an event stream then, basically. And as I say, log all the things. I'm trying to sneak a few memes in here, but yeah. Make use of log levels. So obviously in your local environment, you want to be debug logging to see what's going on in there, but probably not in your production environment. You should tailor this to yourself, or to your application's need as to how much exactly logging you want to do, but as much as you can afford is, I think, the accepted answer. And yeah, with the log leveling, then you can, if you're running tests and you need to go deeper, you can enable debug or trace level logging then to really get to the heart of what's happening in your application. Obviously, and you want to configure this as well. You want to configure the log level so that you can change that in whatever stack. I mean, obviously, don't enable debug logging in production, which you would think goes without saying, but there we go. Yeah, and with Logrus, you're logging to standard out, and then what we do is we collect that with FluentD, and then it goes off to an ELK stack then. So that's Elasticsearch, Logstash, Kibana. We use a hosted ELK stack because, well, it's really difficult to run your own, and you shouldn't, unless you really need to, or if you really love running one, then that's probably best left to someone that you can just pay to do it instead. Okay, cool. So the last one of the 12 factors is it's about admin processes. So these are things that happen in your application that are outside of the normal bounds of operation. So things like database migrations, or you might have, who knows what's going on in your code bases, but you might have like we need to run this command to fix this particular payment because it's ended up in this state. And so you want to, the 12-factor app actually recommends you do this as one-off separate processes, but my recommendation is that you build this into the service itself as much as you can, because it's in the application, it has the context of the application, and it's using the same, it's in the same domain. So for things like database migrations, we use this SQL migrate library, and then what happens basically is when you boot up a new version of your application, it performs those database migrations automatically as part of the rollout then. So you need to be really careful about how you structure your migrations, but they tend to only ever be positive changes, so you're not usually dropping stuff and that sort of thing. So yeah, I mean, it's up to you how much you care about rollbacks, but as we're tending to deploy new versions of our application, you'd prefer a fix forward in that kind of situation usually. And then for your other admin processes, so that you like fix this payment or whatever, you would use either an internal endpoint that only you have access to. This kind of depends how your API is set up. Or you could invoke it via like an SQS queue or a NATS stream. Then your application would listen to this sort of admin commands queue and then enact those, the result of those commands then. And then for regular processing, the robfig cron library is actually really good for just kicking stuff off at a specific time, so whilst your application's running. You can also use sort of an external cron, like SNS notifications in AWS, or there's other tools available for that as well. So we've talked about the 12 factors themselves, and then I wanted to talk about sort of the things that it misses. And I guess it's not about observability, that sort of thing, but that's still a really important part of actually running your application in production. So what I wanted to share was just some wisdom, if you can call it that, on what you should do in terms of observability, what you want to look out for, and essentially a checklist to make sure that you're production ready. So let's talk a bit more about structured logging. So you can, with certain tools, you can do log-based alerting. So your ELK stack provider might provide that, or you can build that yourself in some ways. And you would want to log on things like a number of errors being logged or reaching a certain threshold. You want to log any panics that are happening in your application. And you also want to log things like any specific business logic. For example, if you're using, like we talked about SQS earlier, for like commands as a commands structure, then you would use that the dead letter queue notification to say, hey, something happened in our application, and then we tried to do it X times. Now it's hit the dead letter queue. We should really investigate what's going on there, and then you might want to either replay those DLQ messages, or there's some other action you want to take then. Logging on the absence of logs is really tricky because, for example, you have, if your application is running a cron, it's like triggering a batch every 5 minutes. You might want to have a log that says in the last 10 minutes has no batch been created. But in sort of the ELK world with like log ingestion delays, then it's possible that you get some false positives there. So just look out for that when you're building your alerts. The other thing with structured logging I would recommend as well is that you use correlation IDs, so that you would mint a correlation ID as early in the flow as you can. And you would reference that throughout the flow for the context of that transaction. And then I would say that's a good use of putting inside Go context values. You can fight me outside if you really want to argue about that. Yeah, and I also recommend that you propagate the correlation IDs between your microservices. So if you have like downstream APIs from yours, then you propagate those correlation IDs so that you can see how things have gone all the way through. And we can talk about tracing, but we'll talk about in a second. So the other bit as well is metrics. So you should be logging metrics for your application, as many metrics as possible. Go mad. I mean, obviously don't go completely mad, but never mind. So there's two kinds of key metrics that you should be looking out for. There's the BI metrics, which are things that your service is doing, like payment created, payment updated, payment sent to scheme, or whatever. But then you also have your infrastructure's metrics as well, like the CPU and memory of your application. It depends on sort of where you're running this as to how exactly you set that up, so that's sort of up to you. But then you should also do metric-based alerts. So we talked about our BI metrics earlier, but also for metricing integration with another API or that sort of thing, you want to talk about, like, if X% of requests are failing, then we should probably look into that. That would be captured by the logs as well. So you should have a pretty robust view of what's going on there. And then you have SLA-based alerts. So you have, if you have a service level agreement to say, like, all of the payments should be processed in under 10 femtoseconds, then you want to look at having an alert for if you start reaching that threshold. And then, but if you have a service that has really low volume, then putting alerts on these kind of things is also really tricky as well. So you want to use your best judgment. We talk about, like, an incident management scenario. If one of these alerts is going off and you're waking up at 3 o'clock in the morning, what you want is is everything good dashboard that just has all of the key BI metrics for your services on it, and that just gives you sort of peace of mind then about, yes, everything is running, things are flowing, everything's good. We use Prometheus and Grafana to view these, as obviously really good dashboards in there. Okay, cool. So tracing as well. You want to trace requests in your service and also between services that you own. Usually you would do a representative sample trace of all of your things. Otherwise, it tends to get very expensive. Obviously, that's changing in the future. And I just recommend that you look into the Open Telemetry project. There's loads of good middleware available, and there's a whole ecosystem being built there for standardizing a lot of this sort of thing. Okay, so we talked about observability, and then we also have error handling as well. So things that you should and shouldn't do with errors. We might be going into extreme opinion world, but let's see how we get on. So yeah, error handling, I would recommend you do not panic. Obviously, you don't want your production to completely fall over. Or what I'm saying really is you can panic as long as you are doing that in a situation where you can recover. So for example, like your HTTP middleware, you could have a recovery middleware that stops a single bad HTTP request taking down your entire service. Things where you do want to panic is if your application is misconfigured or you're missing something key and it's never going to boot up, then that's obviously somewhere that you do want to have visibility of and you want to panic. And also, yeah, talking about panicking, structured errors are usually more useful than panic, so you don't want to obviously do it on purpose, but it does happen, I guess. Okay, cool. So yeah, for recovery middleware, like I said, if you're using a framework like Gin or Chai, then this will likely be handled for you, but you should look into it and learn how it works and make sure that that works with how the contract of your API is supposed to work. Okay, cool. And also, my biggest bugbear is documentation as well, and this is something you should put as much time into as you can. I recommend that you have in your service, you have a readme.md that says, what on earth is the service? What is it doing? What does it talk to? What are its dependencies? And if you like, go for a full service diagram. I've also started adding like a cqrs.md file because GitHub now supports Mermaid.js. You can do sort of whole diagram. You can diagram your whole CQRS flow internally in your application. Put that in your application so that when something changes, when you refactor a flow, then you also, in the PR, you have to change the accompanying documentation as well. Obviously, use wikis and other documentation sources, whatever your company is using, for things like deeper design documentation, and you can refer to that from your static documentation, which is your service-specific documentation then. And the other thing I would obviously recommend documenting is runbooks. So these are playbooks for common incident scenarios. If you see something happening in an incident, you know what to do, but the engineer sat next to you might not. And having runbooks for all of your common incident scenarios that you're finding is happening in your application is really useful, because you should be able to log what you want to document is how to do essentially everything that related to what you need to do in order to resolve that scenario. Obviously, there are things that happen that are outside of your expectations. If you were expecting it to create an incident, then you probably would have fixed it before you shipped it. But yeah, so these runbooks should be based as well on incident rehearsals, and so that's something you should do in your team, is run incident rehearsals for common incident scenarios so that it's clear that everyone is on the same page and that people are getting experience in maintaining your application and supporting it during run as well. Shout out to our incident managers, by the way, while we're on it. Okay, cool. So what we've got at this point, or what we should have, is a go-live checklist that describes these are all the standards you should meet for your application in order to be pretty confident that when it gets shipped to production, that we know if it's going to fail, how it's going to fail, we know how to fix that, and we're confident that it works and it runs and it's got tests, and also, when you're shipping an application to production for the first time, it's always more difficult to make wider scoped changes than it would be before you've gone live. So this is why we've sort of talked about some of the 12-factor design methodology stuff. Is you don't want to go back and make those sort of massive changes while your application is already live. I mean, it's better late than never, I guess, but the idea is to build a service that is understandable and maintainable. So, yeah, I mean, that's the first bullet point here, is that your service should be understandable and maintainable. You should have documentation, and your code you should have clean code, whatever that means to you. And it should be easy, to change in the future if anything needs changing. It should be testable. You should have not only unit tests, but we recommend heavily having integration tests and full end-to-end tests as well to give you better confidence in how your actual unit, well, I guess the whole thing that you're shipping is tested. And it also needs, at 3 o'clock in the morning, also needs to be deployable, or at any time of day, I guess. It needs to be deployable, so you need to have a robust CI pipeline that takes your application all the way through the build, test, and run process, and then also can help you deploy that, and that should be as friction-free as possible then. And it should, also something I've not covered on here because I forgot about it, and I wrote my slides, and I finished them already, so I snuck it in here, is having a health check endpoint for your application. So that's really useful for deployment tools, is that they can check your health check endpoint, and if that's not healthy, then it'll stop that application being rolled out then. That's something that's sort of built into Kubernetes, and other tools as well make use of it, and it's also just a really good standard to have. And your health check endpoint should sort of, in the first instance, it should just return OK on v1/health or whatever. But you might also want to check downstream dependencies and make sure that they're up, or that you've managed to load all of your secrets and that your application is ready. That's a readiness check, I guess, which is a separate thing. But if you're there, you already know what you're doing in that regard. And the other bit is, the key part here is that it's observable. So it's easy to understand the health of your application. You know what's going on in there, and it's not just a mystery mystery box of who knows what's going on, and you should have logs and metrics then that support you in that, and make it easier for you to go sort of back to sleep at night if something's happened, and you can go, okay, everything's cool, we can finish, it's time to go back to bed. Okay, speaking of going back to bed, I guess that's the end of my talk. So, thank you.